Okay, welcome back to AP Statistics. Again, I'm not affiliated with the College Board. I teach at a high school where I'm known as Dr. Kling. We're up to Lesson 10, and we're going to ask, are two events independent? So that's our topic for today, are two events independent? So we're talking about two events that are not necessarily independent, and if you remember our favorite example of where event A is the Redskins make the playoffs, B is the coach gets fired, and we said that the probability of A and B is 0.1, probability of A is 0.3, probability of B is 0.4. And the test for independence is the following. We ask, is the probability of A and B equal to the probability of A times the probability of B? And if we do get equals, then we say they are independent. Then that means telling you one event happened doesn't tell you anything about the probability the other event happened. If it's greater than, then we say they are positively related. And that means that if I told you that one event happened, the other event is more likely to happen. And finally, we can have less than, which is negatively related. So if I tell you one event happened, another event is less likely to happen. So in our example, we said A and B, that is the probability that they make the playoffs and the coach gets fired, is 0.1. And A was probability that they make the playoffs was 0.3. And B was the probability that the coach gets fired was 0.4. So if we multiply those together, we get 0.12. And so the relationship is less than, and so we're into negatively related, which makes sense. The coach getting fired and the team making the playoffs ought to be negatively related. So that's the basic point. Now I just want to give another example and then show kind of a common mistake that takes place. So let's say we had a local election. So we're going to have new events. In the local election, the event A is some people voted Democratic. And let's say that the probability of A is, let's say, 0.55. And B is that they were a minority voter. That is, they were from a minority ethnic group. And let's say that the probability of B in our local election was 0.4. And then I'm going to say that of non-minorities, 70% voted non-democratic, didn't vote for the Democrat. Okay, so let's, given that, and then the question is, was voting for a Democrat independent of being in a minority status, being an ethnic minority? Okay, so that's our question. And let me show you a sort of a common mistake that's made with that. So let's see, let's put together the box first. Okay, so we have event A, event B, and we have 0.55, which means we have 0.45 for AC. And we have B is 0.4, we have 0.6 here, which for BC. Now, a common mistake that students will make is they say, oh, I know what I'll do. okay, I'm missing information inside the box, but I know how to get the probability of A and B. They'll say probability of A and B equals 0.4, which is the probability of A, times 0.55, which is the probability of B, equals, what does that equal? 0.22, something like that. And this is wrong. And it's wrong because it assumes independence. So there's a difference between when you can assume independence and when you have events that are possibly not independent. And these are events that are possibly not independent. So we want to work with those. And so what we want to do is go back and make use of this fact. Of non-minorities, 70% voted non-democratic. In terms of our notation, of non-minorities, let's see, a non-minority is BC, and didn't vote Democratic is AC, so the probability of AC given BC is 0.70. Okay, and now we can use that, we can go into this part and use a triangle. Remember, the triangle will have AC and BC, and it will have AC given BC, and it will have BC. So let's use the triangle. We can get the probability of AC and BC is equal to, oops, made a mistake there. So let's do this right. Okay, so we have probability of AC and BC is equal to this times this. The probability of AC given BC times the probability of BC equals 0.7 times 0.6 equals 0.42. Now I'm going to fill in the box properly, so give me a second there. Okay, so we have AC and BC is 0.42, which means if we go up this way, we need 0.03 to make things add up to 0.45. And to go this way, we need 0.18 to add up to 0.6. And up here, we need 0.37. So if we want to see whether A and B are positively related, or independent or negatively related, we need the test. Probability of A and B, does it equal probability of A times probability of B? And we have A and B is 0.37 versus 0.4 times 0.55, which is, I think, 0.22, something like that. So it's definitely greater, and we would say that the two events are positively related. So if we do this correctly, we don't assume independence, we can find out that they're positively related. And next time I'll talk about a mistake that isn't so much common among students, but it is common among doctors. See you next time.